Alright, we've been working with variables. Now we're working with solving equations which have variables on both sides of an equal sign. So not only do we have a variable on this side, we also have another equation where we would normally have a solution. So we need to solve for y in this instance. You still want to isolate your y, but we need to combine like terms. So we need to combine like terms if we can. Combine any like terms. We need to isolate our variable. Then we will get a solution. Alright, so with the 6y minus 7 equals 2y plus 9. I could see that my variable in this instant is the y. Alright, so let's try to keep the y on this side. That means we need to get everything out of y's neighborhood. But I have a y on this side, so we want to combine our like terms. So let's go ahead and do that. Even though it's on the other side of the equal sign, we can still combine them. But we're also going to eliminate it from this side. So let's move this 2y over to this side. How do we do that? We take the inverse operation or the opposite operation. So if this is a positive 2y, anytime there's no sign, we have to assume it's a positive number. So if this is a positive 2y, we will do the inverse or the opposite operation, which is a negative or subtraction of 2y. What I do, our mantra on this one is what I do to one side, I must do to the other, which means what I do to one side of the equal sign, I must do to the other side of the equal sign. So if I'm subtracting 2y on this side of the equal sign, I need to subtract it with its like term on this side of the equal sign. There we go. Alright, so I have a positive 2y minus 2y. That just cancels it out. It zeroes it out. Now on this side, I have 6y minus 2y. That gives me a positive 4y. I still have the minus 7. My equal sign is still there. And I still have this 9. Alright, so now I have a constant here and one here. Now I want to keep my y on this side. I'm isolating my y on this side. So let's get that negative 7 out of this neighborhood. He's in y's neighborhood and y says, get on the other side of the fence. Alright then, 7 says, I will go over to my friend 9. So what is the inverse or the opposite operation? Well, when you have a number, we need to microscope in, zoom in on our number. But we need to include the sign just before our number. So I'm boxing in not only my 7, but also the minus or the negative sign. So with this minus sign, it also becomes a negative 7. So the inverse or the opposite operation of a minus or negative 7 would be a positive or plus 7. Again, our mantra, what I do to one side of the equal sign, I must do to the other. So add my 7 on this side of the equal sign as well. So this cancels out here. Bring down my 4y. My equal sign. Now I have like terms. A 9 and a 7 are both constants. I can combine them. 9 plus 7, 16. Now that's a positive 9 plus a positive 7, which gives me a positive 16. Am I finished? Not yet, almost. I still have not been able to finish isolating my y. So I have 4y. 4y means basically 4 times y. So I want to unglom this y from the 4. He says, again, out of the neighborhood, 4. Move over to your constant. So how do I separate my 4y? Well, the opposite operation of multiplication is division. So I need to divide the 4. What I do to one side, I must do to the other side. So dividing 4 here cancels it out. I still have my y here because all I did was cancel out the 4. Equals, now 16 divided by 4. 4 can be divided into 16. How many times? Well, let me see. I can also turn this into a multiplication problem. 4 times what equals 16? Well, I know 4 times 4 equals 16. So that would mean that 4 is divided into 16 4 times. My answer thus is 4. Y equals 4. Am I finished yet? Well, not really. I need to do a double check. A double check. Let's insert our solution. Now at this point we said y equals 4. Let's insert the 4 into our original equation and see if it actually is a true solution. So if I substitute 4 for y, 6 times, remember 6y means 6 times y, so 6 times 4 in this case, minus 7 equals, then here we have 2, a y, substitute that y for our 4, plus 9. Now let's put some parentheses around our multiplication so we know that this is something we will do first. Alright, 6 times 4, 24. 24 minus 7 and then we have 2 times 4 is 8 plus 9. What does that solve to? 17. Is that correct? Do both sides of the equation work out? Does this solve to 17? 24 minus 7? That is 17 as well. If both sides are equivalent, that means if both sides are equal. If our solution for y solves both of these equations here with the same answer, then our solution is correct. And yes, it did. So we can say we did a double check and we're correct.